Good day and welcome to our class of real analysis. In today's class, we are talking about the convergence and divergence of series. Recall from our knowledge of sequence convergence that we said a sequence is said to be convergent if its limit exists. That means given the sequence a sub n, then the sequence is convergent if the limit as n tends to infinity of a sub n exists. That is, if the limit as n tends to infinity of a sub n equals a finite number, say L, equals a finite number, say L. Otherwise, it is said to diverge. It is said to diverge. That is, if the limit as n tends to infinity of a sub n equals plus or minus infinity or does not exist, then the sequence is said to do what? Is said to diverge. In order to recall our knowledge of limits, because in working on convergence and divergence of series, we'll be trying to recall some of the concepts of limits which we have learned before. So, as a practice question, based on the above, we can try our hands on the following sequence. Determine whether the following sequences diverge or converge. You can try your hands on the following and determine whether the limit of each one as n tends to infinity gives a finite number. If it gives a finite number, then we say that the sequence converges. But if it doesn't, then we say that what? The sequence diverges. In the same way, just as we have done for sequence, we do the same for what? For the series. Similarly, a series can either be convergent or divergent. Similarly, a series can either be convergent or divergent. We recall that we write our series as what? Summation a sub n as n moves from 1 to infinity. Now for this series, this as n moves from 1 to infinity, the nth partial sum is given as S sub n is equal to A1 plus A2 plus A3 plus down to plus A sub n. You will recall this from our video on definition of series. Now, if the sequence of partial sums that is the sequence of S sub n, converges to S, then the series will also converge. Then the series, which is summation A sub n as n moves from 1 to infinity, also converges. Then the series also converges. And this means that what? This means that what? The limit S equals the sum of the series. That is summation n equals 1 to infinity of A sub n equals S. On the other hand, if the sequence of partial sum S of n diverges, then the series also diverges. We take some quick examples and just try to illustrate what we are saying before we look at how to test for series divergence or convergence. Consider the sequence A sub n defined on n. Then the terms of the sequence will be what? 1, 2, 3, 4, and it continues like that. A series for the sequence A sub n, A series is given as the summation as n moves from 1 to infinity of A sub n, and it is seen to be what? The sum of the terms in the sequence. And this is the same thing as saying what? Summation n as n moves from 1 to infinity. However, the partial sums of the series are, we have S1, which is the same as our S first term, and that is 1. Our S2 is the same as the first term plus the second term, or the first partial sum plus the second term, and that is 1 plus 2, that is 3. Our S3 is the same thing as what? First term, second term, third term, which is the same thing as what? The second partial sum plus the third term, and that is 3 plus 3, that is 6. The S4, or the fourth partial sum, is what? A1 plus A2 plus A3 plus A4, and that is what? The third partial sum plus the fourth term, that is 6 plus 4, and that is 10. A sequence of partial sums, the sequence of partial sums is given as S sub n is equal to 1, 3, 6, 10, and like that. We can see from there that as n is getting bigger and bigger, the sequence of partial sums is also getting closer and closer to infinity. As n gets bigger and bigger, the sequence of partial sum Sn tends to infinity. The limit of the sequence of partial sums S is the sum of the original series. What do we mean by that? The limit as n tends to infinity of Sn is equal to S and is equal to what? The summation of as n tends to infinity of A sub n, where S is a finite number, then the series converges. Otherwise, the series diverges. That is, if the limit as n tends to infinity of S of n equals plus or minus infinity or does not exist, the series summation as n moves from 1 to infinity of A sub n diverges. The series diverges. We can also consider another one to further buttress our point on series divergence and convergence. Determine if summation 2n as n moves from 1 to infinity converges or diverges. The series is defined as what? The summation of 2n as n moves from 1 to infinity. But in this series, we have the sequence 2n or sequence A sub n, which is equal to 2n. The terms of which will be what? 2, 4, 6, 8, 10,